In this video, I'm going to go over the concept of reference frame in special relativity. As a definition, I can say a reference frame is a set of coordinates allows us to refer to the position of a particle. So each particle or object can be regarded as a reference frame. I am here, so I can have my own reference frame, my set of coordinates, and through these coordinates, I can identify the location of every object in the space. Also, the driver of that car can have their own specific reference frame, the set of coordinates for the driver of the car. Then they can identify my location according to their reference frame. That's it. It's very easy. It's a mathematical tool to identify the position of particles. Inertial reference frame is also a very important concept, specifically in a special relativity. What do we mean by inertial reference frame? Inertial reference frame is a reference frame that's not accelerated. Consider this car that's at rest or can move at a constant velocity. Constant velocity means it's not accelerated. So it's called inertial reference frame. On the other hand, we have non-inertial frame of reference. For accelerated frames of reference, one or more of Newton's laws of motion do not hold. Look at this car. Let's say there is a pendulum hung from the ceiling. When the car is accelerating rightward, a fictitious force, a spooky force, is pulling the pendulum leftward and is deviated from the vertical. The person inside the train has no reason for that fictitious force. That's why this is not a proper, or let's say inertial, reference frame, and you cannot judge the Newton's laws of motion inside the train. We do not use it, okay? In classical mechanics, it's forbidden to use Newton's laws of motion in a non-inertial reference frame. But more than that, in special theory of relativity is also very important. Because in a special theory of relativity, the basic assumption is that all observers are free from acceleration. So if you are going to use the special theory of relativity, you should be either at rest or moving at a constant velocity. Otherwise, you are accelerated. And then you should learn general relativity. Earth is a non-inertial frame of reference. The Earth is approximately, but not quite, an inertial frame. Coriolis effect is one reason. You should have more study about the Coriolis effect, but it's actually because of the rotation of the spin of the Earth, okay? You know that the Earth is spinning around its axis, and that spin generates a very important fictitious force, which is called Coriolis force. That's why it's merely, not completely, an inertial frame of reference. So ignoring that fictitious force, we can say, yeah, to some extent it is. But we are living on the Earth. Do inertial frames of reference exist? Yes, they do. In principle, they do. The best way to find one is to take a spaceship out into deep space, far away from all gravitational effects, planets, stars, and galaxies, and then turn off the engines. When you turn off the engine, you know it's not accelerating anymore. No forces are acting from outside on the system, and so basically, yes, we can say this system is a kind of inertial frame of reference. We can use that. Thank you for watching this video. Please keep these concepts in your mind, and from now on, when I talk about special relativity, we always consider an observer living in an inertial frame of reference. See you.